Okay, so we're doing the Pythagorean theorem today. Yesterday we classified triangles by their angles and their sides, and then learned a couple of theorems. Today we're going to use the Pythagorean theorem for right triangles. That's really what the rest of this unit's going to be about, right triangles. There's going to be a little at the end of today about acute and obtuse triangles, but the bulk of the unit is right triangles. So without further ado, let's get to the Pythagorean theorem. Now, if you were in class week before last, when we actually no, it was last week, when we introduced the Pythagorean theorem, I gave y'all a little tidbit of information that the Pythagorean theorem is probably the most famous mathematical relationship. However, Pythagoras did not come up with it. I mentioned that it was known way before him. He lived in the 6th century BCE, but ancient civilizations such as the Babylonians, the Egyptians, and the Chinese knew about it. He was just the first to be able to prove it rigorously, which means show mathematically that it works without fail in every single situation. He was able to do it, so he got to slap his name on it. That's the thing about math. Before you can name a theorem, you have to show that it works in every single situation before you can like, oh yeah, this relationship exists. Because someone is out there trying to prove you wrong. Someone's out there trying to prove you wrong. So Pythagoras was the first one to say, nope, this works in every single relationship. And let me show you. And so he proved it what's called rigorously. Now, we've talked about the Pythagorean theorem. We know it's a squared plus b squared equals c squared. Now, let's say a, b, and c are all whole numbers. This would be called a Pythagorean triple. A Pythagorean triple. Again, it's when, for the Pythagorean theorem, they're all whole numbers. No decimals. So let's look at example 1. First thing I want you to do when solving the Pythagorean theorem, label your C. The C is always across from the right angle. That's our C. Yes, I know they call it X, but that is in our theorem. In our theorem, that is our C. I don't care the order you put the 3 and the 4 in for A, it's 3A, is it B? It doesn't matter. As long as C is where it's supposed to be, you'll be good. So let's look at number 1. X is our C, so I can write this as 3 squared plus 4 squared equals c squared. Well, 3 squared is 9, plus 4 squared is 16, and equals c squared. 9 plus 16 is 25. So then I'll take the square root of 25 and I get 5 for C. So that means X, because really I should have used X here. That means X equals 5. Like, wait a minute. You had C, then you had X. Well, yes, X is my C. So X is our C. So yes, X is 5. Now, that means this is a Pythagorean triple. This is one of our Pythagorean triples. You don't have to memorize these. You do need to know that if they're all whole numbers, it works. So 3, 4, 5. That's a Pythagorean triple. Any multiple of 3, 4, and 5 is a Pythagorean triple. So I could do 6, 8, and 10. That's a Pythagorean triple. I could do 9, 12, and 15. Pythagorean triple. This is your base triple. One of your base triples. Okay, number 2. First step, label the C. In this case, X is our C because it's across from the right angle. Okay, so now that we know where C is, I can plug in 9 squared plus 15 squared equals, I'm going to go and say X squared because that's what we're solving for. The first one I said C because I know a lot of y'all are used to A squared plus B squared equals C squared. Let's get in the habit of putting the actual variable in there. It's not C, it's X. Okay, 9 squared is 81. 15 squared is 225 equals X squared. 81 plus 225. Let me do that right quick. 81 plus 225. 306. So 306 equals X squared. We've got to square root it. And then let's see what happens. Square root 306. 17.4928558. Yeah, whatever. I tried to do it too fast. See if I can do it again. 17.49285568845. Got it. That's our answer. It's ugly. It's nasty. It says to, let me move this over here, round to the nearest tenth. That's 1 decimal place. So I'm going to look here. I want to round that 4. 9, so I'll look at the next one. 5 or more, raise the score. 5 or more, raise the score. That's a 9. That's more than 5. So I'm going to up that to 17.5. So that means X equals 17.5. This is not a Pythagorean triple because it's got a decimal there. It's not a whole number. So it's not a Pythagorean triple. Let's look at number 3. Number 3, again, first step, label the C. I go across from my right angle. There's my C. That's the hypotenuse. Notice this time that the C actually has a value. The C is 13. So if I'm plugging into my Pythagorean theorem, I'm going to say something like 5 squared plus X squared equals 13 squared. I actually now have to do a little bit of work to solve for X. That's why I didn't just, oh, well, I'm going to just type all this in the calculator, square root it, there's my answer. That's what a lot of people try to do on that distance day assignment. where you did the distance formula and the Pythagorean theorem. You just want to type it all in the calculator real quick and get your answer. And then you're done. Let's actually work the squares out. So 5 squared is 25 plus x squared equals 13 squared is 169. I can't just add 25 and 169. They're on the opposite sides of the equal sign. Remember, the equal sign's like a river. Unless you got a boat, you can't go across it. So I need to move this 25 over by doing the opposite. Subtract 25. So give me x squared equals 144. Then I can square root it. And you get x equals 12. Here's another Pythagorean triple. You're like, what's another Pythagorean triple? Well, x is 12. So that means our sides are 5, 12, and 13. They're all whole numbers. Those are Pythagorean triples. Again, it's one of our basic ones. What I mean by basic is you can multiply them and make them bigger. Like if I wanted to, I can make this 10, 24, and 26. That's a Pythagorean triple. Because you divide it all by 2, you get 5, 12, and 13. Just like I said up here, I can make this one 9, 12, and 15. So even the multiples are Pythagorean triples. Okay, number 4. Solve for x, round to the nearest 10th. So remember, 10th means 1 decimal place. So get your C. It's going to be that 21. So this problem is going to be like number 3. We're going to have to say 13 squared plus x squared equals 21 squared. That means that 169 plus x squared equals, I think 21 squared is 441. Let me double check. Boom, shakalaka. 441. Okay. So now I need to just get x squared by itself. So subtract 169. It's going to give me x squared equals, let's see, it's going to be a 2, 72, I think. Yep, 272. Okay. So now let's square root 272. And I'm going to guess it's going to be a nasty decimal because it says round to the nearest 10th. So let me just check my math here just to make sure before I square root it. Yep, 272. Now let's square root it. Yeah, nasty decimal. 16.4924225.025. Okay, so 16.5 is this decimal. Again, on this one, it's not a triple. It's got a decimal. Now let's go on to the back. We're still dealing with the Pythagorean theorem. I do not know why this y is so far up here. Let me fix it. Good down there. Okay. So they want us to use the Pythagorean theorem to find the value of x and y. Well, what you want to look for first on these is a triangle, a right triangle that has two sides already found. Well, we've got two options. I can go with the left triangle or the right one. I'm going to go with the right. You're like, well, why? Well, because I know it's 9. I know two sides, 9 and 15. I can make an equation out of that. So on this one, look across. The 15 is my C. So I can say 9 squared plus y squared equals 15 squared. I think this is going to be one of those triples we just talked about. So I got 9 and 15. 9 squared is 81 plus y squared equals 15. Oh, 15 squared is 225. Why am I writing that again? 225. Move the 81 over. I mean, y squared equals 144. Square root the y squared, and you get y equals 12. Yep, this is one of those triples. Y is 12. Okay, so if y is equal to 12, how much do I have left for this side over here? Y is 12. How can I figure out what I have left? Well, 25 minus 12 gives you 13. So for this side, I'm going to have 13. That's not a good choice of pen. Red on pink is not good. Let's do purple on pink. Now I'm just erasing everything. Baby, come back. There we go. Okay, so now I can use the 9 and the 13 to help me get my x. This is another right triangle. And don't you dare say x is 15. No. Our pink side is 13. Y is 12. They're different. X can't be 15. We have to use the Pythagorean theorem again. X is our C. So we can say 9 squared plus 13 squared equals x squared. 9 squared is 81. 13 squared is 169. 81 plus 169 gives you 250, I believe. 81 plus 169. Yep, 250. So 250 equals x squared. Square root that. $15.8. So 15.8 is my x. See, I told you it wasn't going to be 15. It's not, it's larger than 15. It's 15.8. X is 15.8. You're like, well, 15's close. Close enough. No, that's not. Close enough was what caused one of the space shuttles to explode. That sounds really, really bad to say, but that's exactly what happened. You're like, oh, close enough. I'm like, oh, that's close enough caused the space shuttle to explode. You're like, what do you mean? Well, when Columbia exploded over this area, it exploded because some screws vibrated loose and part of the heat shield fell off. How did they vibrate loose? They were just slightly too small. Slightly too small. And they just sit there and vibrated until they fell out. And then the heat shield fell off, and when things went boom. So, anyways, number 6, same process. I want to start with the triangle that has 2 sides already in place. This time it's going to be this one over here on the left. That's where I want to start. So looks like we're starting with y again. Imagine that. We're going to start with y again. Okay. So let's see here. I need to get my seat. That's my first step. Look across. There's my seat. Square root of 34 is my seat. So 3 squared plus y squared equals the square root of 34 squared. Well, 3 squared is 9 plus y squared. Square root of 34 squared is just 34. Move the 9 over. You get y squared equals 25. Square root that, and you get y equals 5. There's our y. Y equals 5. Now we can do the x over here. So again, look for your seat. There's my seat. I'm going to have 5 squared plus x squared equals 11 squared. I was about to get ahead of myself. 5 squared is 25. 11 squared is 121. Subtract 25 from both sides. That's going to give us x squared equals 96. Square root that, and you get x equals, that's going to be a decimal, but let's see. Second square root 96. Oh, what are we doing here? $96. There we go. 9.8. So x is 9.8. So remember, the key on this to remember, start with the triangle that has both sides, or has 2 sides. You know 2 of them, you can find the third. If you just know one side, it's kind of hard to find the third side. Okay, so now let's talk about how to figure out if they just give you three sides, they don't tell you what kind of triangle it is or any of that. They just give you three sides. Then how can you determine what kind of triangle? Well, we can use a version of the Pythagorean theorem to do it. And here's how you can do that. Now, me personally, I don't like these formulas like this. We're not used to seeing c squared equals a squared plus b squared. We're used to seeing a squared plus b squared equals c squared. So if you want to cross out this version and rewrite it, you can. Same down here. A squared plus b squared is less than c squared. Cross out this version. Over here, a squared plus b squared is greater than c squared. Cross out this version. That's how we're used to dealing with it. So what you can do is see, okay, the smallest two are my A and my B. So just like yesterday where we had to add the smallest two sides and see if it's greater than the third, all that jazz. The smallest two sides are my A and my B, and then we've got to compare it to C. If it's equal, then it's a right triangle. That's what we've been doing today. If a squared plus b squared is less than c squared, it's obtuse. If a squared plus b squared is greater than c squared, it's acute. So let's use this for these next four examples. First thing it asks us to do is tell if the measures can be the side lengths of a triangle. If so, classify it as acute, obtuse, or right. So remember, we need to add the smallest two sides together and then see if it's greater than the largest side. So let's do that first, because if it's not, then we're done with that problem. We don't have to go any further. We are done. So I'm going to go and we're going to do all four of these and see if they can be a triangle. Then we'll go back and see what kind. So add the smallest two. 7 plus 12 equals 19. How does that compare to 16? 19 is greater than 16, so we are good here. Next one, smallest two sides. Don't tell me 11 plus 34. That's not the smallest two sides. It's 11 plus 18. That's going to give me 29. Is 29 bigger than 34? No, 29 is less than 34. Therefore, 8 is not a triangle. So I'm going to put that here, not a triangle. We're done with number 8. So when we go back through these, we do 7, we skip 8. It's not a triangle, we don't need to go further. Number 9. 8 plus 11. That gives us 19. Is 19 greater than 13? Yes, we're good. And then the last one, add the smallest two. 5 plus 12 is 17. Is 17 greater than 13? Yes, we're good. So we got rid of one of them. We got rid of 8. 7, 9, and 10, though, we're going to have to do work. So here's where you want to compare a squared plus b squared to c squared. So I'm going to do 7 squared plus 12 squared. Leave a space and see how that compares to 16 squared. Well, let's see, 7 squared plus 12 squared. It's going to be 49 plus 144, which gives us, yeah, let's just do this here. 49 plus 144. 193. Okay, 193. 16 squared is 256. Which one's bigger? 256 is bigger. So a squared plus b squared is less than c squared. This is going to be obtuse. Okay, 8 we can skip. It's not a triangle. So go to 9. 8 squared plus 11 squared. And then compare that to 13 squared. 8 squared is 64 plus 11 squared is 121. That's when you compare that to eventually 169. So I'm going to just write it down here. Okay, 64 plus 121. 64 plus 121. 185. Okay, so this is going to be 185. Which one's bigger, 185 or 169? The 185 is bigger. That means this one is acute. Okay, and then last one is number 10. So I need to compare 5 squared plus 12 squared to 13 squared. So 5 squared is 25 plus 12 squared is 144. Together, that's going to give me 169. 13 squared is 169. Those are equal. What kind is equal? That's right. Pun totally intended. Okay, so there's our crash course in the Pythagorean theorem. And we used it to find sides of the triangles. And then we used a version of it to figure out if they are a right triangle, an obtuse triangle, or an acute triangle. So this is the lesson for day 2. Stay tuned for the guided practice.